Alright guys, we're starting our fourth unit, our last unit for the semester, and it's our geometry unit. So today is going to be a lot of highlighting of definitions and things like that. There's not a lot of problems to do, so it's a lot of review. A lot of review of like 7th and 8th grade math. So here we go. So 3 undefined terms, Euclidean geometry. Okay, Euclidean geometry starts with 3 undefined terms, which is point, line, and plane. Okay, the reason they're called undefined is because we can't actually draw them. Yes, you go point, that's the dot. We represent it with a point, but it's not actually just one point. So the 3 undefined terms: point that which has no part, a line that has length but no breadth, and a plane that has length and breadth only. Okay, it's easier to say about a line, okay, than trying to describe a point, because a line doesn't have thickness, but it goes on in both directions. So we're representing part of a line when we draw this. Okay, so couple things you need to know about points. We label points with capital letters. We label lines with lowercase letters. Okay. Any point that a line divides on a line divides the line into 3 parts. The point and 2 half lines. Okay. Array is a half line with the endpoint included. Okay, so I'm just going to put a little box around this. Hopefully you remember what array is. It has an endpoint and then keeps going in one direction. This half line right here, the point would not be included. Okay, and this is a line segment. Okay, a piece of a line joining 2 points and including the points is called a line segment. All right. Although we do not try to define precisely what a plane is, you can think of it as being an infinite 2-dimensional surface that's an infinitely large flat sheet of paper. So it could be like this, but the sides keep going in every direction. Okay, so we're just going to highlight that. Also, lines either intersect or are parallel. Okay, if you have more than one line. Parallel lines are lines that lie on the same plane and have no points in common. Okay, it's like train tracks. They run side by side, but they'll never touch. Okay. All right. And if 2 different lines lying on the same plane are not parallel, then they have a single point in common and are called intersecting. That's where the 2 lines touch. The intersection is that. Okay, so here's a visual of parallel lines and intersecting lines. Now let's do this little quiz yourself right here. I want you right now to try to identify what these things are. Okay, based off of what we've learned so far. So if you want to pause it and do that, and then we'll check our answers. Okay, so we had questions A, B, C, and D. So A has 2 ends that go on and on forever. This, my friends, is a line. B has 2 endpoints with a line piece connecting them. This is a line segment. C has an endpoint and it goes on in another direction with that endpoint included. So this is a ray. And D is similar, but the endpoint's not included, so this is called a half line. That might be a new phrase for you, because it's not one we talk about often. All right, moving on. 2 rays having a common endpoint form an angle. In this figure right here, we form an angle by a rotating ray called the initial side. So that's the starting side. And a ray, angle used to be, back in middle school you called it, two rays that share a common endpoint. And I hated that definition because it's like just two random lines joined together. No, it's really just one ray that moves. So it starts here and it ends here. So we have a terminal side, and where it ends is initial side where it starts, terminal side where it ends, and then your vertex is the point about which it rotates. So I'm just going to block this off so you can visualize that. And then the initial side about a point B in a finished position corresponds to a ray BC called the terminal side. Okay, we use the symbol that looks like an angle to denote an angle. Therefore, we can call this angle ABC or simply angle B. Now, if you want to label it with 3 letters, remember your vertex has to go in the middle. So this could be CBA or ABC. The vertex has to be in the middle. Point B is called the vertex of the angle. We also measure angles in units called degrees. The degree symbol represents the word degrees. If you rotate the initial side of an angle 1 complete revolution, that's a 360-degree angle. Okay? So if you start and end at the same spot, that's 360 degrees. If you just go 1/10 of a complete rotation, complete revolution, that's 36 degrees. Okay? Alright, so we have that. Alright, let's go to the next page. Figure 9.6 shows a tool called a protractor. Okay, you have a protractor right here. If you were in class, I would pass out some protractors so you could see how they work. An angle whose measure is between 0 and 90 degrees is called an acute angle. Hopefully you remember that. A right angle has a measure of 90 degrees. Okay. And a obtuse angle has a measure between 90 and 180 degrees. And a straight angle has a measure of 180 degrees. Okay, so 45 degrees is an acute angle. 90 degrees, remember that makes a little square there. It makes a corner. Obtuse means bigger than 90, but if it's straight, it's 180. Okay, 2 intersecting lines forming pairs of angles are called vertical angles. Okay, so vertical angles have equal measures. So what I like to say about that is you have 2 lines, they create 2 angles. These angles are equal. If you think back to when you marked things being equal, you put a little line there, and that means that this one's equal to this. And then if you had markings here, you put 2 lines here and 2 lines here to let you know that those 2 are equal to each other. Okay? We call a pair of complementary angles, a pair of angles complementary if their sum adds up to be 90. And the way I remember that, because some people say, oh, I confuse complementary and supplementary. Well, complementary makes a corner, C for corner, C for complementary, and that's 90 degrees. Now, if 2 angles have an angle sum of 180, they're called supplementary. Well, 180 makes a straight line, so S for straight and S for supplementary, and that means 180. So if you look here, if I add this angle to this angle, they will make a 90-degree angle when put together. If I add this angle and this angle together, they make a straight angle, which means they're supplementary. So I'm just going to box this in. So if you need to look back at that. Now, I want you to look at Quiz Yourself 2, and I want you to try to determine what type of angles are shown in this graphic. So pause it and give that a shot. Okay? So A, those are vertical angles. B, that's a right angle. C, if I put these two together, they make a straight line, so that's supplementary angles. D, this is more than 90 degrees, so that's an obtuse angle. And this one's less than 90, so this one is an acute angle. All right, like I said, there's not a lot of problems here. Now this next piece we're going to take slow, because this is the part that people mess up on in geometry, and it's the part that people mess up on in discrete. Okay, so we intersect a pair of parallel lines with the third line called a transversal. So we have parallel lines here, and this is a transversal. Okay, now corresponding angles. Okay, corresponding angles mean that we have, and I'm going to write this in pencil right here, one outside, one inside, same side, don't touch. Do not touch. Okay, so if I go one outside and one inside, but they can't touch. Okay, these are outsides, these are insides. Okay, so 1 and 5, 2 and 6. I'm going to list these here. 2 and 6. The next set, 3 and 7. Okay, 4 and 8. And what we need to know about this is corresponding angles have equal measures. Okay, so the first type of angle we're looking at is corresponding angles. Okay, the next one tells you the definition. Alternate interior angles. Opposite sides inside don't touch. Do not touch. Okay, so they're on opposite sides inside, but don't touch. Okay, so that's going to be like 3 and 6. And then we can do, let's do this in green, 4 and 5. Alternate interior. Okay, and alternate interior angles are equal. Now, alternate exterior, same thing, but they're on the outside. So, opposite sides, outside, do not touch. Okay, so opposite sides, but can't touch. So that's 1 and 8 and 2 and 7. Okay, so let's make this blue. 1 and 8, 2 and 7. Okay. Notice that all 3 of these say do not touch. When they don't touch, they are equal, like that, okay? So interior angles of the same side. This has a totally different name to me, okay? When I learned it, and when every other textbook I've ever looked at, they call them same inside interior angles. Why they wouldn't call that now, with it being alternate interior, this should be same side interior, which means same side inside, okay? Same side and inside. So that's going to be 3 and 5, 4 and 6. Notice that there's not a do not touch. So if they touch, if it's same side interior are supplementary angles. Okay? So their sum is 180. So I'm going to put here same side interior angles are supplementary. Okay? And once that dries a little bit, I'm going to highlight it. I just don't want it to smear. It's still going to smear because I'm not patient. Yep. Not patient. So it smeared a little. Okay? So, let's see. On this one, fill in the blanks using angles other than those mentioned. So we've already done this, but we can fill it in again. So angles 2 and 7 are alternate exterior. Corresponding 4 and 8. Same side interior are 4 and 6. Alternate interior are 5 and 4. Okay, so this next one's just a smidge tricky because you have 2 transversals here. Okay, it says, it gives you an angle here, okay, and it gives you an angle measure here. So what we're going to do is find the measure of angle 2 and 9. All right, so let's go to angle 9 first. Okay, always start with looking for a vertical angle. So step 1. Angle A is 51 degrees. Angle A and angle 10 are vertical. Okay? Now, so they are equal. All right? So that means that 10 is also 51 degrees. Now, if I look here, 9, 10, and 11 make a straight line. So I need to find out what 11 is. Well, if I look right here, what are these two to each other? They're inside, but opposite sides. What do we call that? They're alternate interior. So step 2, angle B is 76 degrees. Angle B and angle 11 are alternate interior. So they are equal. So angle 11 is 76 as well. Now, step 3, and it's little puzzle pieces, okay? Angle 9 plus angle 10 plus angle 11 equal 180. And I'm going to put in parentheses here, straight line. So we're going to say angle 9 plus 51 plus 76 equals 180. Angle 9 plus 51 and 76 is 127. Then we move the 127 over by subtraction, and angle 9 is 53 degrees. Let me move this 9 down a little bit. Okay. All right, cool. Now let's find B. Okay. Now, an angle A and angle 2 are same side interior. So they equal 180. So I know that A is 51 plus angle 2 gives me 180. So when I subtract the 51, angle 2 is 129 degrees. Okay, and I'm going to put this as 53. Okay. Now, look at the quiz yourself. Look at this again. Find the measure of angle 7 and the measure of angle 6. Alright, so we're going to come right here and say angle 7 is supplementary to angle B. Okay, so angle 7 plus 76 degrees equals 180. We subtract the 76, so angle 7 is 104 degrees. Now, we can do this. Angle 6 is vertical to angle B, so they are equal. So angle 6 is 76 degrees. Okay, so also 8 is 76 degrees, so we can find that easy. 7 is going to be 104. 4 is going to be 129. Then we could do our supplementary angle thing to find 3. And it would be equal to 1. 9 is 53, so 12 is 53. Do you see how you're just finding the pieces? Okay. All right. Next, circles. Okay. A circle is the set of all points lying around a plane that are located at a fixed distance called the radius from a given point called the center. Remember, the diameter is the line segment that passes through the center with both endpoints lying on the circle. The circumference is the distance around the circle. Okay, so I'm going to put this, box this in. Okay, you have a circle. Distance from the center out is the radius. All the way across is the diameter. Distance around is circumference. Okay? An angle that has its vertex at the center is called a central angle. Okay? So that means it's like cutting a piece of pie. Cut it to the center. Okay? The length of the arc. When I talk about arc length, I talk about it looking like the crust. Okay, how long is your crust? How long is this arc? Okay, so this is the formula. What is the measure of your angle? So it's part of the circle out of the whole circle. Okay, so this angle out of the whole circle, so part out of the whole. Then we want to know the length of the arc out of the whole measure, which is the circumference. So it's always part out of the whole. Okay, so if you can remember that, you do the angles, you do the lengths. Part out of whole. Okay, so for example, if your angle is 60 degrees, 60 out of 360 is 1/6 of the circumference. So let's look at this one right here. Okay, assume that a circle has a circumference of 12 meters. Okay, I want to underline that. Circumference, 12 meters. If the central angle has a measure of 120, what's the length of the arc? Okay, what's the length of the arc? So we're going to set this one up. Remember, it's angles first. So the part we know is 120 out of the whole circle, which is 360. We want to know what's the arc length of AB. We don't know that. Out of the whole length, which is circumference, which is 12. Now we just do the butterfly method and solve. So 12 times 120 is 1440. 360 times x is 360x. And you can kind of see this one going on right here. Okay. Then we divide by 360. And the answer is 4. So arc length of AB, and you can write that as AB equals 4, and it's in meters. Make sure you put your units of measure if they tell you the units of measure. Okay? Now, we can use this to solve some meaningful problems. Okay, so let's do this last example here. Let's do the quiz yourself first. Assume that a circle has a circumference of 40. So that's the whole distance around the circle. Central angle has a measure of 45 degrees. So that's the part. What's the length of the arc determined by the sides of the angle? Okay. So we do angle first. The part we know is 45. Out of the whole circle, 360. We want to know the arc length out of the whole circumference. So 45 times 40, that's 1800. And this is 360x. So we divide by 360, and that gives us 5. So that's going to be 5 inches. Okay? Alright, now, let's look at this. Consider the figure below. Assume the lines L and M are parallel and cut by the transversal T. The point C is the center of the circle. Therefore, angles theta and beta, okay, are equal. So that's theta and beta, okay? From our earlier discussion of central angles, we see we have the following ratio. Okay, the angle over the whole circle, arc length over the total circumference. We can now make our estimate by placing, we're going to estimate the circumference of the Earth, by the way, by placing a vertical pole in the ground and waiting till high noon when the rays of the sun and the pole form an angle of 0 degrees. Suppose at that very moment you're talking to a friend who lives 1,000 miles away who also has a similar vertical pole. Your friend tells you that the sun's rays make an angle of 15 degrees with his pole. Redrawing the figure as this, we see how to find our answer. Okay, now look what they said. The distance between us is 1,000 miles. So what do we know this time? We know that the 1,000 miles is our arc length. They want us to find the circumference. Do we know our angle? Yes. Our angle is 15 degrees. See, it tells us here, 15 degrees. Okay? So set up our proportion now. Our angle over the whole circle, arc length, and we want to know circumference. So this is 15x equals, there's 4 zeros, so 1, 2, 3, 4. So that's 360,000. We're going to divide that by 15. So the circumference of the Earth is approximately 24,000 miles. So you just need to know the distance between you and another point and see what the angle, sun's rays make an angle of 15 degrees with the pole. Okay? You didn't have to get out a measuring tape and try to drag it around the Earth, which is silly. You can't do that. Okay? So easy peasy lemon squeezy. Let me know if you have any questions. Have a great day.